Okay, welcome back. Today we're going to look at synthetic division of polynomials, so as an alternative to using long division. You'll see pretty quickly the advantages to it. It's particularly nice if we have a simple divisor, something with a coefficient of 1 on the x. So starting point, basically we're looking to take from this term the restriction on the division. So you've done restrictions before. You want to remember that since I'm dividing by this value, provided this value is not 0, everything's okay. So the restriction here would be that the divisor itself cannot equal 0, which means that x cannot be 4. That's the value I'm actually going to use to do the calculation. The rest of the setup here will be using the coefficients of the various terms, 2, -8, -6, 32, and 32. And basically the process is fairly straightforward. We start with the 2, and essentially what we're doing is we're adding down the column. There's nothing to add here, so just the value 2. Then we multiply the 4 out front by the 2 right here and write the result here. So we've got 4 times 2 is 8, so it's the 4 times the 2. The 8 goes in here. Again, we're going to add down the column. -8 plus 8 is 0. Multiply across 4 times 0, obviously is 0. So 4 times 0, the answer goes here. Add down the column, -6. 4 times -6 is -24. Add down the column is 8. And then 4 times 8 is 32. Add down the column. Now the key here is that knowing we're dividing by this value, this term, what we end up with is fewer terms in our result. And so the last value here is always going to be the remainder. So this is a 0 remainder, and then this represents the quotient from our division. So we've divided this by this, and this is the result. So our final, if we rewrite this then, and actually I should go back to writing in red here. So 2x to the 4th minus 8x cubed and of course this is the same thing as what I had above there. Now if we work backwards, this is my constant term, this is my x term, this is my x squared, and this is my x cubed. So I have 2x cubed, 0x squared, minus 6x, plus 8. The 0 remainder will come into play in the next little bit. An alternative here, I suppose, would have been to write this as a factoring type question. And again, we'll see where we're going to use this in the next day or so. And so I could write this as this original question is equal to the x minus 4 times the 2x cubed minus 6x plus 8. Okay, so I'm not going to go through this too much, but I've just brought up the original question here done as a long division. Just wanted to make a quick association. If we look, first of all, I guess recognize the result here, the quotient 2x cubed plus 0x squared minus 6x plus 8 is again what we said we had from the result of the synthetic division. But sort of just kind of looking at the values here, we had the number 4, and here we ended up with an x minus 4, Here we ended up with an 8 as we went through the process, and here we have a -8, a 0 and a 0, a -24 and a +24, and a +32 and a -32. And so just sort of recognizing that while this process seems a little strange, I think the logic in the long division probably makes a lot more sense to most people. It looks like something you've done before. You're using exactly the values that you had all the way through. There is an association here where I'm essentially using a lot of the opposite values to do the work, but in the end it does work out nicely. So we're going to do a second example down here. This one's not going to be quite as nice, but just showing that it can be done, and the simplicity that you gain through synthetic by not having to put all the x's down all the time, is made up for a little bit here in this question. So again, starting with, we want the restriction on the question, and if I'm dividing by 3x minus 1, that means that 3x minus 1 cannot be 0. If we simplify that, add 1 to both sides, divide through by 3, that means that x cannot be 1/3. So now, right away, I'm sure a few people have started to cringe, thinking working with the 1/3 is not very nice. And again, it's sort of made up for by the fact that we'll have a lot less writing throughout the question. This time I'm going to add in a little bit of an extra line here, knowing that this last spot over here is where my restriction will be, just kind of separating it. Here's my restriction, whatever value ends up there. Now 6 comes down, again adding 6 down through the column. Now one of the things that will happen here sometimes, or often, 1/3 times 6, we have a multiplication, and as long as the denominator from the fraction divides evenly into this number, of course we'll get rid of our fractions, and that'll be nice. It'll kind of keep the question simple throughout. We can get other fractions throughout, but as long as we're not making the fraction worse each time, it's not too bad. So 1/3 times 6 is 2, and in case anybody's forgotten how to multiply fractions, we rewrite any numbers as fractions with a denominator of 1, and then in theory you multiply through the numerator and through the denominator and simplify. You can also recognize that 6 divides by 3 at this point, and sort of whatever works for you there, you end up with 2/1 or just 2. So 2, add down the column, -2 plus 2 is 0. 1/3 times 0 is 0, so that one worked nicely for us. -18. 1/3 times -18 is -6. 15 minus 6, or 15 plus -6, is 9. And then 1/3 times 9 is 3. Add down the column. Remainder is -2. We've got our first remainder this time. So we'll sort of see two things here at once. Now if I write this out, kind of what I've just determined is that so this is equal to, in the synthetic division what we determined was that this would be equal to, now it's not exactly what we were looking for. What you want to recognize here is, even though I used the 1/3, if we're going back to what we did last time, technically what I was working with then was dividing by x minus 1/3. Not exactly what I was supposed to be working with, but the synthetic division using the 1/3 is really kind of as if I was working with this instead. And so the rest of my question, again, constant x squared, x cubed. And then the remainder, if this had divided evenly, we would be done at this point. The remainder is a minus 2. And so we have this minus 2 on the end. Now, knowing that or recognizing that the question I did at this point is not really what I had wanted to work with, isn't a problem. You can see in my second expression here, I have a common factor of 3. And so if I factor out that common factor of 3, so 3, I'm left with 2x cubed here. I'm left with minus 6x and plus 3, and minus the 2 on the end. And then this 3 can be multiplied through the first, or the first factor here. This is 3x. 3 times negative 1/3 is minus 1. And now I have the solution for the division that I actually wanted. So this divided by this would give me this, or this can be broken into this factored expression with a minus 2 remainder on the end.